This lesson is for the third day of Unit 4. So today we started with a warm-up. So you should pause the video, try the warm-up, and then play to check your answers. So the first one, GCF, is the quantity 2x plus 1 squared times the quantity x minus 3 squared. So when you factor that out, you're left with a 2x plus 1 squared, and then a plus sign, and then an x minus 3, the quantity, to the first. So when we square the binomial correctly, we get 4x squared plus 4x plus 1, and I'm adding on x minus 3 to that. And when I combine like terms, 4x squared plus 5x minus 2. Okay, and if I check that, it's out of the way here. If I check that, negative 8 would be the top, 5 would be the bottom. Factors of 8 do not add to 5. So the quantity 2x plus 1 squared times the quantity x minus 3 squared times the quantity 4x squared plus 5x minus 2 is the final answer. The next one, trinomial, no GCF. So we can go right to our binomials. We know that 3x and 2x are going to multiply to give us 6x squared. And we want something that's going to multiply to negative 18 and add to positive 7. So, and also something that's going to multiply to 3. So I'm going to try 3y and 1y. Or I can flip it around if I need to, but 3 times 3 is 9, positive 9xy, and then in this inner, negative y times 2x gives negative 2xy, so 9xy minus 2xy gives us 7xy, and then negative y times positive 3y is negative 3y squared. So our factors are 3x minus y and 2x plus 3y. Looks good. Next one, simplify. So that simplifies to root 2 over root 5, but we talked about how that's not simplified, so we're going to rationalize the denominator by multiplying by root 5 over root 5. Root 2 times root 5 is root 10, and root 5 times root 5 is 5. Root 10 over 5 is the final answer. Okay. So yesterday, if you recall, we talked about how to write an equation in vertex form if we knew the vertex and one other point. Now, in this example, you'll see that we know 3 points, but none of them are the vertex, or at least we weren't told that. So we cannot use vertex form here because remember, h and k are needed, and we don't know h and k. So we'll instead use standard form, which we remember that from yesterday. Let's substitute in the 3 coordinate points. So if I put in 3 for y and 2 for x, I get that. I'm going to simplify. 3 equals 2 squared is 4, 4a plus 2b plus, I'm going to rewrite that as 1c. I'm going to do the same thing with the other 2 coordinate points. So 6 equals the quantity negative 1 squared times a plus b times negative 1 plus c. So if I simplify that, 6 equals the quantity negative 1 squared is 1. 1 times a is 1a, and I'm going to write that as 1a instead of just a. This is negative 1b and plus 1c. And I'm intentionally writing those coefficients because it'll make my next step easier. last point becomes equation 3 equals a times 0 squared plus b times 0 plus c. And so I'm going to simplify that. So 3 equals 0 squared is 0. 0 times a is 0a. I realize I wouldn't have to write that, but again, I want the coefficients. So plus 0b and plus 1c. So now this should be, we're in a familiar place. We have 3 equations and 3 variables. So we know a couple different ways to solve this system of equations. We could use the fact that if you look at this third equation, we actually know c is equal to 3. We could use that and then substitute into these two and pretty easily solve the system of equations from there. If we wanted to do so by hand, but we also could, if we wanted to solve the equation system of equations quicker, we could use matrices, which we also did in Unit 2. So I'm going to take these equations and I'm going to put the coefficient matrix 4, 2, 1, 1, negative 1, 1, and 0, 0, 1. And now you'll see why I suggested you write 1a, negative 1b, 1c, and same thing, all of the c's put 1. Because then you can just pick the coefficients right off. Okay? And then our variables, a, b, c, equals, and then our coefficient, or our constants, 3, 6, and 3. So if you recall, we called this coefficient matrix A, we called the variable matrix X, and that equals the constant matrix, which we called B. So if you remember how we solved that, we multiplied both sides of the equation by A inverse. And A inverse times A is I. And I times X is X. So X is equal to I inverse times B, or A inverse times B. So that's what we do in our calculators. If you recall, we're going to put A into the calculator, we're going to put B into the calculator, and we're going to multiply A inverse times B, and that will give us X. Okay, so take a moment to do that. Okay, so when we do that, putting both in and finding A inverse times B, we do get 1, negative 2, and 3. Now that doesn't answer my question, and if you remember in Unit 2, our goal at that point was to solve the system of equations. So we wrote that final solution as a coordinate point. Here, I don't necessarily need to write the solution as a coordinate point because my goal wasn't to solve the system. Solving the system just allowed me to know the A, B, and C values. So now we're going to use those A, B, and C values to write the equation. So we're going back to y equals ax squared plus bx plus c. Y equals a. So a is 1, so 1x squared, plus bx is negative 2, so negative 2x, or just minus 2x. And c is 3, so plus 3. Okay. And that's the equation for the parabola that goes through those 3 points. Now, one note, when you're substituting in, remember you're substituting in for A, B, and C, not X's. So when you substitute in here, be careful. It's negative 2x. It's not negative 2b. That's a common mistake I see is you're kind of forgetting what you're substituting in for. Just be careful. You're substituting in for A, B, and C. So here's another one for you to try. I kind of had students try this one in class, so you should probably pause the video and try it, and then play to check your answers. So we started off the same way, substituting in the x and y values. Simplifying. Second equation. It's a positive one. And third equation. Okay, so our matrices, 9, -3, 1, 1, 1, 1, 16, 4, 1. Variables, and then -7, -3, and +21. Okay, so we get 1, 3, and -7. And that's our equation in standard form. Okay. Next, these look like, they should look familiar to you, they should look like the solutions that you get using the quadratic formula when you're solving for x, and that is what they are. In geometry, you were probably told that you could just type them in the calculator and get the decimal approximations. Well, in Algebra 2, it's important that we know how to simplify them and get the exact answers rather than the decimal approximations. So that's what we're going to look at here. So the first thing I'll do is rewrite square root of 27, that's 3√3, and that's over 9. Then the next thing you'll do is you'll check this number here in front of the plus minus and after, and you'll check to see if there's a common factor, which there is. So I'll factor that common factor out, 3. And when I do that, 3 divided by 3 is 1, plus minus 3√3 divided by 3 is √3, and that's all over 9. So now that I've factored that out, I'm able to simplify. 3/9 is 1/3. So final answer is 1 plus or minus the square root of 3 all over 3. So let's apply the same thinking here. So 3 plus minus 3√3 again over 5. So this time though, if I factor out the 3, 3 and 5 don't simplify. So factoring out the 3 really didn't do anything for me. Therefore, you can either just stop here if you recognize that 3, 3, and 5 don't have a common factor, or if you want to factor it and go the following step, that's fine too. Either would be fine for an answer. Next one. So 5 plus or minus the square root of 24 is what, 2√6 over 2. 5, 2, 2, there's no GCF there, and therefore that one's done. Next, 8 plus minus root 16 times root 2 is root 32, so 4√2 over 4. So I'm factoring out a 4. And the 4's simplify. So 2 plus or minus the square root of 2 would be the final answers. Okay. All right, that's it for notes for today. So your homework tonight is page 4 in the Unit 4 packet, and then in the simple radical practice, page 4 also. So page 4 in both packets for tomorrow.